So we learned about two different approaches for initializing a chain of connected nodes. And let's see one step further. How can we really build an actual singly linked list object whose head will just be the starting point of the chain of nodes? So that's something we'd like to see. It's incredibly easy, given we have done so much already to set up the groundwork. All right, if you go back to the slides, and these are the two approaches that we just spoke about in the earlier part. And let's now move on over here. The only thing in terms of visualization that we have added is, you can see this is the list object over here for singly linked list, whereas the head is simply pointing to the chain of nodes over here. So even up to this point, you will be able to kind of imagine how exactly the Java code that should be written, right? You can even pause the video and think about it, and then before going over the solution with me. Let's talk about it, assuming that you may have paused the video and thought about it. Let's now talk about approach number one. Up to this point, so this is what we talked about earlier to build the chain of nodes. And let's now bring the singly linked list into context. And what we're going to do is create a new one, empty, and then set the head to be the beginning of the chain of node, which will be Alan, right? That's something I'll show to you. Visualize a bit. Just, again, call by value. That's so important to understand. And approach number two, we're just going to set up the chain of nodes using approach number two over here. And then we're going to bring the singly linked list into context, which will set the head to be also Alan, right? So you can see the only difference is we either build a chain of nodes using approach number two, or we use approach number one. And then the way to really set the head to be the Alan node, for example, will just be the same. Right? That's the main thing. And then once I visualize that very quickly together with you, I want to show you how you can see all these constructions using Eclipse debugger, which will be very important later on if you want to debug your algorithm on the linked list. All right, so this would be, let's see over here. So let's take a look at the class that we are looking at right now. So the new class I want to include now. So let's not worry about the node class. It's not relevant in this case. It's still relevant, but we simply assume you have done the object instantiation already. So we got singly linked list over here, and the only attribute that we need will be the head for now, right? And also we will need this particular set head method, which will be very important for us. And that's where the call by value will actually occur to make everything work. Let's now talk about it, all right? And over here, so the 3 lines in the beginning about how to set up Tom over here, and also how to set up Mark, and also how to set up Alan, right? So these are the 3 lines which we spoke about in detail in the earlier part of the lecture, right? So this part here, I assume you already know, right? Let's leave it alone. Let's now talk about how we can visualize these 2 lines, which will bring the singly linked list into context. To start with, and when I mentioned earlier, so based on the slides, we did not include explicitly the constructor for singly linked list. So in that case, this will be the default constructor, which will simply assign all the attribute value. For example, head to be just null, right? So you can either put it over here, or you can initialize it in the constructor, right? It's or implicitly or explicitly. That's kind of completely up to you. But let's say just make it explicit for illustration. I'll just put null over here, right? All right. Let's now talk about how this line can be visualized. We want to create a singly linked list object and store its reference into the list. That's what we want to do. Let's now do it. So list will store the reference to some singly linked list objects over here, right? So the title over here, rather than node, you can see these are just simply nodes. But this one here is going to be singly linked list, right? That's kind of the visualization we talked about earlier. And the only attribute that we have to worry about is the head over here. So I'll put a head over here. And in the very beginning, by the default constructor over here is simply going to have the default value null, meaning that in the beginning, this list is simply just empty, right? It's very important for you to know this over here. So when the head reference is actually null, so that means the list is empty. That's also something we spoke about when we talk about the intuition, right? So let me just say that over here. So the head is simply equal to null, means empty list. All right. Let's now talk about the second line. The second line over here, call by value. We're going to call the set head method over here, right? So call by value. Let me try to point it out again. Okay, let me try to avoid crossing the line as much as possible. But over here, right, you can see this is a parameter, and this is the argument, right? And we got call by value. So call by value. So call by value over here is going to assign the argument to the parameter. So n will just be pointing to wherever Alan is pointing to. So Alan is currently pointing to this node. So the parameter n is going to point to wherever Alan is pointing to. And when we try to execute this line over here, this head over here, implicitly it really means this dot head is assigned to n. And what is this? This right now should be corresponding to the context object, which is list over here, right? So that means this will just be the list. So we are really saying that list.head is actually assigned to wherever n is pointing to. So that means it is going to point to wherever n is pointing to. That's what we can do. Agree? All right, so what we're going to do is we're going to say the head, rather than pointing to over here, it is now going to point to wherever Alan is, whatever n is pointing to. Let me try to draw a little bit better so you can see all the arrows that are involved over here. All right, so that's it. This part over here is a chain of nodes that we did earlier. And then the only thing extra we did is to initialize some syncly linked list objects. And then we actually make sure the head is pointing to the beginning of the chain. That's what we are doing. That's what we have done. And later on, when we talk about other operations on this on the syncly linked list, we always assume we always have to start with the head reference of some list. All right, that's something we got to do. Okay, and when we get to that operation level, we're gonna visualize the object slightly differently, just to make it easier for us to draw. But for now, I think knowing how to draw things like this is actually very beneficial, because you know exactly how the memory has been structured to really support such construction of the list and also the chain of nodes. Right, so that's number one. Number two will be extremely similar, right? Let me say that hopefully within a minute. Okay, I think about for completeness, let's talk about it as well. Syncly linked list, right? So we talk about the head, and also we talk about the set head method over here. And the only part that's actually different is really this part over here. Let me highlight it. So this part here is really about approach number two, to really create a chain, which we also talked about earlier, right? You can think about this part over here has the result of a chain of nodes like this, right? All the three lines. So we got Tom over here, and also we got Mark over here, and also we got Alan over here, right? That's something you assume you know. And also we got a corresponding call of the set next to really set their connections. And these two lines are exactly the same as over here. Right, for that one, for the call by value, I'll let you practice about it, but let me just visualize once more. Okay, so we're going to create a list reference variable, which will actually store the reference of a syncly linked list objects over here, which would be SLL, right, just for short. And then the only attribute we're considering right now that's relevant is the head reference. Initially, it is simply just pointing to null, denoting an empty list. But after this second line, we want to set the head to be wherever Alan is pointing to. So the head will be, rather than pointing to over here, it's actually going to point to wherever Alan is pointing to, right? Maybe as a side note about reference aliasing, which is so important, right? Let me highlight this, and then let's say this. Okay, so here is my question to you. How many paths using the dot notation are there possible to reach this particular node over here? How many? Okay, let me write out the question. Meanwhile, you can think about the answer. That'll be some exercise for you. Okay, let me maybe use a purple is okay. Question. How many paths to reach the Tom objects. Alright, you can pause the video and think about it. Alright, assuming that I thought about it, let's see on the diagram how many. Well, first one, just Tom. Second one, Mark dot get next. Third one, Alan dot get next dot get next. And fourth one, list dot head dot get next dot get next. Right? That's these are the four. Alright, let me write it down over here. Number one is simply just Tom. And number two would just be Mark dot get next. Or you can just yeah, that'd be more valid because only we should only try to get to the private attribute using a public accessors. And number three will be Alan dot get next dot get next, right? And number four, which is kind of special, it will be basically the list, right? Let me just put it here, right? Number four. There are four in total. It's going to start with the list dot. Later on, you're going to see that we actually got a method in the source code that I made available to you. So there is a method called get first, which will give you the head of the list. Get first, right? So if you say list dot get first, it's going to give you the reference of the head. And then we're going to follow the same reference over here as we did for get next and get next, right? All right, and then dot get next, and then dot get next. So it's very, very important for you to see exactly how each one of them is actually doing, right? Let me just trace this one specifically together with you. So we start with the list over here. So list is this reference over here. Dot is going to look up its address and go to the objects. Get first is going to return the reference for the head over here. And then dot is going to go to that particular objects. Get next is going to get its particular next over here, right? And then dot is actually going to go to that particular objects over here. And then get next is going to give you this reference over here, and that's really referring to this particular objects over here, right? So that's it. If you try to say dot get next, that will be basically equal to null, right? So that's it. You don't really go any further. So that will be, so this part over here is will denote the reference or address of this particular objects. That's really what's happening. So you got four in total. All right. So you got one. Let me just thicker. You got 1, 2, 3, and also 4 in terms of reference aliasing.